Well, good afternoon. I am the last thing between you and cocktail hour, so I appreciate I've got the graveyard shift here. The talk, Who's Going to Make Money in AI? Really the genesis of this talk was over the past 2 years, been having a lot of conversations with people about AI, reading a lot about AI, and I realized one thing, there's a lot of confusion as to what is AI and what's absolutely going on with AI at this point. Talk to my mother, she's terrified that the robots are coming to get her. If you talk to public policy figures, the ethics of AI overrides everything else at this point. If you talk to corporates, there's very much a sense of they know that AI is important, but there's an absolute fear of missing out. And then if you talk to the practitioners of AI, there's a lot of eye rolling, because when you get into things like hyperparameter tuning and the challenges of scaling, and you talk to the CEO, there's a massive disconnect between the practitioners, the business people, the policy people. So this is the genesis of this talk here. So I want to go through and look at the questions of the landscape and dynamics of AI. How do we actually understand AI? Who's making money and winning with AI, and who will make money with AI? And it's just some really interesting questions there. And then what does that mean for key players? If you're in corporates, what does that mean for you? What's your strategy for AI? If you're in a startup, what should you be doing given that this landscape of AI is evolving very quickly? And if you're an investor, how should you be investing? So in terms of my background, I'm co-founder and partner in a company called bestpractice.ai, and I'm a bit of an odd breed because I've really worn 3 hats in my career. I started my undergraduate was a degree in artificial intelligence when the computational power equivalent of an iPhone would have cost $50 million. Let me assure you, we weren't doing anything particularly interesting in AI all those years ago. And the second hat is I switched to the business side and been doing commercial and digital. And my third hat is really working with startups. And I put that all together in this company called Best Practice AI. And we're really an executive advisory that helps startups, corporates, and financiers accelerate their adoption of AI practices. Based here in London, and clients include the likes of Bloomsbury AI, Selden, we work with finance as well. Now, for those who are old like me, and actually there is a colleague of mine who did the same undergraduate degree many years ago, he's sitting over there in front, he got a PhD in AI. I wasn't as smart as him. But we know that AI is a story of many boom and busts. So a question for you is, one of the godfathers of AI said within 10 years a digital computer will win the world's chess championship. That was Alan Newell from CMU. Anyone hazard a guess as to which year he said this? Come on, somebody must know which year this is. 1970, 1980s, what do we have? Okay. Anybody else?
62.
Okay. 1958. Herbert Simon, again at CMU and considered one of the founders of AI. Machines will be capable within 20 years of doing any work a man can do. Want to have a guess as to which year? Go on, Richard. 61, 1961. Marvin Minsky, brilliant guy from MIT. Within our lifetime, machines may surpass humans in general intelligence, AGI. And we're still having that debate about AGI today. That was 1961, he said that. Unbelievable. And then within a generation, I'm convinced the problems of creating AI will be substantially solved. Unbelievable, 1967. So we've been here before. We've had this debate about solving AI problems, general intelligence versus narrow intelligence, that we're going to solve it within a generation. And in the 60s, there was an AI hype wave around mathematical symbolic AI, followed by a 1970s bust. It hit the UK here very hard because AI funding was pulled from the universities in the 1970s, with only 2 universities remaining on AI funding, Sussex University, where I went to, and Edinburgh University. We've had this bust before. 1980s, 5th generation in Japan, expert systems, followed by a bust in the 1990s and 2000s. And 2010, 2018, AI is back. I have the misfortune of graduating right here at the start of the bust. So the question is, are we ready for another AI gold rush? Because clearly, if you read the headlines and believe the headlines, it's all going to happen. AGI is going to be solved over the next few years. We're all going to lose our jobs. It goes on and on as you read the clickbait of the headlines out there. But the reality is there is something different going on about AI at the moment. And for those who have been involved for what feels like eons, the power of exponential. And a few figures here. Storage is 28,450 times cheaper than it was in 1993, the power of exponential. The iPhone would have cost a computational equivalent $50 million back then, actually probably more because the iPhone is actually increasing every year in terms of computational power. 1.7 megabits will be created by every single person on the planet every single second in the year 2020, it's projected. And then if cars had increased at the same speed or power and ratio as computational chips from 1971, cars would be driving at 420 million miles an hour. Now this is actually from a slide last year, so you could probably double that at this point. And then the other side of what I think is exponential decrease in the cost of AI software and frameworks, which is basically everything's being put into open source at this point. TensorFlow, Keras, we talked about all of those today. You know, and just over the past week, we've heard of PyTorch from Facebook going into open source, and even Microsoft getting into the game with their open sourcing of infer.net. So there is something different that's fundamentally going on at this point. That is this wave of exponential power such that this boom and bust is different? That's the question. So one of the things we did is trying to understand this as all the activity going on in AI, the new sort of wave, is who will capture the value in AI. So we came up with a technology stack, a value chain, you can call it what you want, trying to map out where the value is going in AI. And it seemed to us that at the bottom of all of this is chips and hardware. Every AI program out there is going to need to run on chips and hardware. So there's a race going on amongst the various chip players out there today to see who can provide the best AI chips. And you obviously see Intel has got a big stand over in the exhibition area. But then on top of that, we've got a race in the cloud going on for AI, platforms and into infrastructure. Who are you going to run your AI on? In which cloud, in which platform, in infrastructure? And then there's a race going on for frameworks and algorithms. Is it going to be TensorFlow? Who's got the best algorithms for speech, NLP, and semantics? And there's a whole big fight going on and race in this area as to who will be the underlying frameworks and algorithms for the AI. And then enterprise solutions as we move up. Every enterprise, big organization, they've been using software like IBM and Oracle and Salesforce to do their CRM and marketing. Who's going to be the predominant players as we look into the future for enterprise software, because all of this software is going to be AI powered. And then we go up, we see in the AI is starting to power new solutions in healthcare and finance. We heard earlier about Zest Finance. And we keep on going up, and then there's corporates and enterprises. Those are the ones that would be using AI. Who's going to win it in that game? And then finally, there is a massive race going on at the nation level around AI. And we'll dive into all of these areas a little bit more later. But is it going to be the US that's supreme here, China, UK? Which nations are really going to capture the value from AI? And so this is a model that we've been playing around with. So I'll go through each of them a bit more. Firstly, the chips. I mean, a friend of mine, very smart guy in the Valley, said, oh, this AI stuff, it's just a bunch of tensor calculations. This machine learning, deep learning, yeah, it's just input, output, and a massive sort of deep network in between. It does it a bit of a disservice, but underlying, obviously, machine learning is trillions of tensor calculations. And whilst the demand is increasing faster than the price that chips are going down, and then we have chip makers such as Intel making sure that they would stay relevant, and then NVIDIA kind of got lucky at this point. Their stock is up 1,500% in the past 3 years. And what they realized is their chips that would traditionally great for doing games and drawing and rendering polygons of games. Their chips were suddenly bloody good at machine learning here. And admittedly, whilst there was a crypto craze, they're great at actually deciphering crypto. And then you've got Google starting to offer its own chips, its tensor processing units, Microsoft its brainwave AI, and there's rumors even that Facebook is starting to build and design its own chips for AI as well. And then you have startups like GraphCore, raised over 110 million to build their chips specifically around effectively graph calculations. And then China, in the midst of this, has very modestly said, we want a chip industry, let's put 140 billion allegedly into this race. So the winners in the sort of the chip space and the hardware space will really be the few and the massive. If you're building and designing chips, think of manufacturing plants, you better have a lot of money. And you better have a lot of expertise here. And frankly, if I'm a little guy standing here in London, I don't want to be starting a chip company anytime soon, unless I'm a genius, which I'm not. So in some ways, the semiconductors are going to be the picks and shovels of AI, we believe. They're going to be underlying everything. It doesn't matter who's doing AI. Everyone's going to be using chips behind this. And if we go on, we've all seen, obviously, that Amazon really pioneered the cloud category back in 2006, and it was great to go to their session earlier today because they talked about how everything is containerized, and it's so easy to do image recognition, object recognition, and obviously roll it up on their and run it on their platform. Microsoft is doing great these days with its cloud. Google Cloud, ironically, Google is actually slightly behind in the cloud races, and you see them rushing to catch up at this point. And then we also see that Alibaba, don't forget the Chinese, are pushing very heavily into the cloud services as well. So the winners, again, we believe, are going to be the big and the massive here. And organizations are going to continue to rent or increasingly rent compute services and platforms as opposed to buy it. And again, we believe that the winners here are going to be the big technology companies, the picks and shovels of AI. So then we go on to, this is a really interesting area, best frameworks and algorithms. We're seeing sort of the rise of AI as a service starting, APIs and alike, but they're happening around obviously the frameworks and some incredible frameworks. But you talk of looking at somebody like Microsoft, their GM, David Carmona, says there are 1.2 million developers using our cognitive services, while 300,000 using our conversational AIs. That's a massive developers out there using the underlying AI algorithms and frameworks from Microsoft. And so there's this big battle going on, Google, Amazon, Microsoft, IBM. Now, the interesting thing is here, and I wish I were 25 years younger with a PhD in AI, because the big guys are in a massive talent war to pull out the best AI researchers. And literally, you're seeing $1 million annual salaries for the best PhD AI researchers to help them build their cognitive algorithms and things. One of our clients was Bloomsbury AI, which was about 7 guys in London, about 4 PhDs, a few of them absolutely brilliant. And Facebook just came in earlier this year, swept them up. Team's expertise was in NLP and helped them with all of their NLP efforts. And whilst the financial terms were not disclosed, Facebook is paying between 25 and 30 million according to TechCrunch. So the point is, there's an absolute massive talent war going on for the best AI PhDs out there between the giants. So we think the winners in the sort of the frameworks and algorithms would be the big guys with the big checks. Now, the question is, where can startups play in all of this? Because if we go around London, there's 700 AI startups allegedly in London. A lot of them have NLP, and a lot of them have AI as a service. Where do they fit into that? And the challenge is, if you're a startup going up against the giants, is you've got to make sure you're doing something unique, special, and not directly in the crosshairs of Google or Microsoft or Amazon. So again, we believe the sort of the picks and shovels will be the people, the companies that actually prosper here in this area. So I won't spend too much time on this, but the enterprise solutions, as we know, enterprise software has traditionally been really led from the valley with platform ecosystem companies like Salesforce, Oracle, Microsoft up in Seattle, SAP in Germany, IBM, New York. So but now what we're seeing is the enterprise players over here, the traditional, are starting to get challenged in different areas. There's a lot of opportunity for startup companies to take specific discrete problems and solve them in the enterprise. So we see simple things like in customer service, Digital Genius raising 25 million. ZipRecruiters, this was last week, just raised a further 160 million. HireVue's raised 93 million to accelerate video interviewing. UiPath, which is RPA's, raised 400 million. You can argue whether or not it's really AI, but the sums of money that are going into the startups is absolutely huge. And we see tools companies like Pattern has raised 100 million. I really like the last guys with their synthetic data, and they will be a tools company to help accelerate AI. And then, as always in a gold rush, the consultancies providing services are doing very well and will do very well providing advice. IBM is here. I haven't seen Element AI here, a Canadian company. They're doing some really interesting stuff. But the incumbents are not standing still. If you're a big giant of a software company, you're not going to let these upstarts or startups get in your way. So what we've seen is a lot of activity going on by the big guys around adding AI to their enterprise offerings. Microsoft announcing new AI mixed reality business applications for Microsoft Dynamics. Salesforce strengthens its AI capabilities with an 800 million purchase of Datorama, basically an AI company. SAP has made some announcements in AI. Google announced a suite of updates to its contact center tools. Google's starting to push up that stack into enterprise software. And Google, this was a few days ago, Google acquires AI customer service startup Onward. So there's a race going on here between the incumbents, the big guys trying to stay relevant, and they've got a good position to be, and those of the startups that are trying to get into the enterprise. Just check on time here. So if we go to then, sorry, lots to scroll through. Then we look at vertical solutions, which is really you're providing a solution to specific industry challenges. Could be healthcare, could be finance, could be agriculture, and lots of different sectors. And again, we're seeing that there are lots of AI-powered startups raising tons of cash. Earlier, presentation talked about Zest Finance raising 217 million. A firm that offers loans to consumers at the point of sales raised 720 million. Absolutely huge sums of money involved here. And I can go through the list. Benson Hill has raised over 95 million in agriculture. So there's this massive race to create startups in these verticals that will create scale. So again, those who will win in this area are likely to be those who can gain scale in terms of data, absolutely key, capital, talent, along with leadership in their category. I spent a bit more time on this. Corporates, enterprises, big companies, small companies. How would they benefit from AI? They're not necessarily going to be creating AI frameworks or tools or software, but they're going to be actually applying AI to their business. So Gartner research predicts that AI-derived business value will reach up to 3.9 trillion by 2022. And the corporates, as I said, are not standing still. They're very much thinking about AI. And there's a big question mark around how much AI is actually happening in the enterprise today. One figure I was hearing earlier today suggested that only 4% of companies or enterprises actually have some serious AI in production at this point. But what we will see is, we will hear of talk of corporates using chatbots. And I wish we'd stop talking about chatbots because there's really distraction, no disrespect to top bots. But it's because chatbots are so readily understandable, a lot of people just focus on chatbots as being really the face of AI. But AI is so much more than that. AI is being used in diagnostics in healthcare, predictive marketing for marketing and sales, and a myriad of other use cases. But the headlines are creating confusion and fear very much of mass job automation. I mean, there was a report that came out of Oxford in 2013 talking about 30 to 40% job loss. So one of the things we try to do at Best Practice AI is really take a closer look at what is happening in the corporate environment. And so we put together something called the Best Practice AI Library, where we analyzed over 10,000 articles and curated and created 600 use cases and 850 case studies to try and get a sense of what's going on in AI. And this spanned multiple industries, multiple functions and the like. And this is actually the map of what we ended up with. And this cluster here is the density of vendors in AI, which is obviously North American and would be heavily Silicon Valley as well. The other one was the UK here at the top. So what we found, and in some ways no surprises, most of the use cases, and use cases are how do you use AI against a business problem, a business task, a business activity, are in sales, marketing, and customer service at the top there. We saw that there's a lot of use cases for AI in supply chain operations, and then in R&D. And R&D would include product development, could be pharmaceutical product development, and alike. We actually found a lot of use cases for IT, for AI in IT. So this is sort of our map of functional use cases, and it's illustrative, it's hard to see here. But let's take something like marketing, which is up the top here. What we found with marketing, in purple is marketing, then there's the use cases in blue underneath that, is take something like marketing research, that area. We found these use cases associated with it for marketing research. And then if we take one use case, which is personalized product recommendations, we found in yellow were the actual case studies. That's examples of that use case being implemented in organizations. And against that, we tried to map out basically what are the benefits associated with that use case, what is the data, the technology, but it's trying to build a map of what's really going on with AI at this point. And it's free to use on bestpractice.ai, and we're very much encouraging people to add their case studies to it. Then we looked at where are the most use cases across industries and sectors, so not by function like HR, operations, finance, but rather by industry. And what we saw is the most use cases were in the consumer goods and services industry, financial services industry, and healthcare. And so looking at the map of industry use cases, we take something like healthcare here, then we have healthcare providers and services up there, and around the healthcare providers and services are all the different use cases we found. And then if we take one particular use case in the healthcare providers and services, this is diagnose known diseases from scans and images from things like MRIs, then we found all of these in yellow were actual case studies where that use case was being done. And it's really interesting in the healthcare industry how much is actually going on. And it makes a lot of sense because if you think about taking pathology slides, MRI scans, vision is actually quite good if it's in a constrained problem. So we're getting a lot of use cases, case studies around diagnose for certain diseases based on pathology scans and alike. So saying all this, where's the value in corporate? And I put this up here, this image, and I digress slightly here, but when I published an article about who's making money in AI, I had a picture of the gold rush, and I got a few clicks like that. As soon as I put in this bloody robot picture with money on it, it was absolute clickbait, and the number of clicks went up sort of 5 by 10-fold. I digress, but the key point here is what's happening is we're sort of anthropomorphizing AI at this point, and that's what's terrifying my mother, and I think this does a big disservice to us as an industry, but I'm doing it because it gets me more clicks on my article. So what's actually going on in, if we look at case studies, you might think chips. We actually think more like potato chips. So some of our case studies here, this is a great one. This is what we found in our research, is QPie is a Japanese food manufacturing company used to deep machine vision identify defective potato cubes on the production line. So machine vision, very good, production line of potatoes going along, it's actually found out this is a good potato, this is a bad potato. We went on, the University of Lincoln is also looking at potatoes here as well. And then we go on, and McCain Foods is planning image recognition algorithms for crop condition monitoring to optimize potato yields and things. So when you think of AI, you probably think revolution. But actually what we were seeing in our case studies is much more evolution. There's lots of little use cases going on across organizations. So you might ask, well, where's the meat? And we see meat and veg. This cucumber farm in Japan is in a pilot because it's trained TensorFlow on 7,000 images of cucumbers. And there's 6 different types of classification cucumbers, and they're applying these algorithms in their farm to help classify. It was a massive exercise because it was a family-run firm that did this. We see other things. I love this one. This is Connectera, Dutch company backed by English, and it's got Fitbits for cows. And it's absolutely done an amazing job at applying machine learning algorithms to basically predict patterns from Fitbits to see the health of the cows and improve things. And again, this is the stuff you don't hear about what's going on in AI. Keep going on this, where if you eat too many potatoes, let the machines diagnose you. I love this one here. Socialize diagnoses diseases in places where doctors are scarce by scanning the human retina with neural networks at the edge. So basically a phone can scan your eye and predict whether or not you've got some sort of disease. It's an amazing case study. Cure AI can detect critical head traumas or stroke symptoms with a 95% accuracy, which is up at the level, if not exceeding, doctors. A great one. And similarly, researchers at University of Washington exploring diagnosis of early onset of pancreatic cancer. It's great. And it's actually this cluster of use cases around diagnostics. We found about 30 or 40 examples going on here. I won't go through all of these, but in the future, you're going to be able to get health and car insurance, basically. Lapetus is a Tesla platform to assess your smoking status and other health indicators using selfies for insurance purposes. Looking at selfie, are you a smoker? You said no on your form, but looking at your picture. And we go on. Allstate is offering pay-as-you-drive plans, car plans based on measuring and analysis of customer real-time driving behavior. And it's using some advanced ML analytics there. I can go on. The banks will lend you money. Badu does underwriting for consumers with limited credit history using machine learning. A lot of people are actually not able to get credit because of traditional metrics. Tala in Kenya extends loans to 150,000 Kenyans based on their mobile phone data with a 90% repayment rate on $50 microfinance. Basically, your patterns of movement behavior are being analyzed through the phone, which suggests whether or not you're going to be a good candidate for microloans. Branch grants loans to apps users based on alternative data, contacts, social media, and so on. And so this fun, we had a lot of fun going through this. I won't go through all of these, but there's a lot of case studies in manufacturing, in supply chain, making sure the goods are good. So as the goods go down the manufacturing line, are they quality? And then making sure that the right goods get into the shops. And unfortunately, AI will always be with us in death and taxes. This is a proof of concept. Luca has developed a chatbot which imitates people alive or deceased using a corpus of their text communications. And there was an example similar to this where an AI researcher, his father was dying, and he recorded him and has a voice chatbot basically of his father. I mean, it's sad in some ways, but incredible what he was able to achieve. Danish emergency services dispatchers 911 999 identify heart attacks in real-time emergency calls with 95% accuracy compared to 73% for human dispatchers. So basically when somebody's on the phone, the analysis in the background can determine whether or not it's likely to be a heart attack much more reliably. New York State Department of Taxation and Finance increased its collection from delinquent revenue by 8% using reinforcement learning. Okay, so all of this says, and there's loads of case studies, that AI is basically an enabler and will create value across millions of organizations. AI is very much like databases in the 1980s, SQL databases. In their own right, SQL databases didn't do much, but they did enable millions of applications. And the same thing is happening with all the tools, models, and algorithms. Jeff Dean of Google Brain said there are 20 million organizations today that could benefit from machine learning. And each organization could end up using AI and machine learning across hundreds of use cases. So the key point is, regardless if we're at 4% production today of AI, it is going to be massive and it's going to be woven into the fabric. I will keep going. So our take on AI is that its stage it's at the moment is much more about an evolution than a revolution. The headlines talk about the revolution and the transformation, but we actually think it's not here that everybody's talking about, it's over here. And that's what we need to watch over the coming years, because it's like a rising tide that will impact organizations. We won't go into this in much detail, but it's fascinating to watch the competition going on between countries at this point. China develops the big fund. France announces a 1.85 billion investment in AI. The UK announces a 1.3 billion investment in AI. Europe announces a $22 billion AI investment. And then Chinese city of Tianjin sets up a $16 billion AI fund. You know, the scale of what's going on is amazing. China, there was an article, ByteDance is said to be valued at over 75 billion in a new round, an AI company. And these are some of the top Chinese unicorn companies. So again, scale is absolutely critical in AI. And there's very much a race going on to see which nations are going to extract the most value from AI. So what does all this mean? And I apologize because I've been running through this very quickly, it's a lot. But what we see is AI is really moving from what we call a craftsman phase to an industrial phase, where scale and simplification is critical. If we go back to the early days of the Industrial Revolution, there were a lot of craftsmen who come up with textiles, weaving, tailors, that sort of thing. They were really specialized. But then what happened is that specialism got simpler. And so we started getting factories where you didn't need as many skills. You didn't need to be a craftsman to create clothes and textiles. And then you suddenly got scale here, absolutely massive scale, 150 years. So the little old craftsman here disappeared, and industrialization meant that the big guys really won that. And we see the same thing is going on in AI at the moment. There's a lot of craftsmen dabbling in NLP with a small company. And then you've got the giants who are going to be coming along with their NLP. But we're also seeing simplification, something like chatbots that used to be really hard to do are now relatively easy to do. So which means what we feel this means is really for corporates is got to get moving. But get moving on building a portfolio of use cases that will help you make sure that you're improving your business relative to what AI can do. I won't have time to go through all of this, but the types of use cases, don't think about the transformation. Think about the small use cases, point solutions that can really start moving the dials here. So use cases in marketing, where you can improve customer retention by 1%, that starts to move the needle. So on point 2 here, what we believe is that corporates should be focusing on point solutions, small problems, not boil the ocean problems. A lot of the problems that AI are solving today are actually existing data analytics, big data problems, but it's a new set of algorithms to do better prediction. One of the things that we're very sensitive to, and we see a lot, is corporates need to solve constrained problem spaces. If you have a multi-dimensional space and problem, like unlimited chatbots where you can talk about anything, you're going to break it. If you're going to put in chatbots, then make sure it's a defined and refined space. Object recognition we're seeing is working very well when you've got a defined set of objects to classify in a pretty controlled environment. So we believe corporates really need to be starting on their evolution and journey now and building a portfolio of use cases across their organization. Final point, and this has been made by some of my colleagues already today, AI has to have executive support. It has to be top-down. Projects will get lost unless there's a CEO or C-level who's championing it. For startups, and we work a lot with startups, they've got to focus on high-value use cases and get scale in data, capital, and talent. One of the things we've seen with AI startups around London is they're generally B2B focused. They're providing solutions to enterprises. But the challenge with enterprises is their sales cycle can be anywhere from 12 to 18 months long. And that's something that a lot of startups are not experienced with and will stumble over. So to maximize their chances of success, they've got to focus on a high value problem that keeps their clients awake at night. What we've seen is a lot of entrepreneurs go into a corporate, they get a meeting with the CMO or something like that, but they're talking about a problem that is not at the top of the list of the CMO. If the CMO is not worried about, if the startup's not worried about something that keeps the CMO awake at night, then it's hard to get attention. And obviously, startups need access to unique data sets, especially labeled training sets, deep knowledge and expertise, deep pockets. As we've seen, if there's a theme, hopefully, that comes out here, is how much money is being put into these startups. And then access to really good AI talent. And finally, the ability to bridge between the technical, engineering, and commercial. And if nothing else, get a really great team and flog yourself to one of the giants for millions. That will put a smile on, it can put a smile on your face. And then for investors, the industry is moving very, very quickly. So the startup that you can invest in over here in NLP today might not be relevant next week. So it's really important that for investors, they find investments that have defensibility and scale. So summing it all up, it looks like the tech giants are really the picks and shovels of this gold rush. And the tech giants are in chips, they're in platform and infrastructure, they're models and algorithms, and they are pushing up into enterprise and even into vertical industry solutions today. No matter what happens in the AI industry, no matter if there's a bust, the picks and shovels guys will be making a lot of money here. Unfortunately, the reality of any gold rush is many of the gold diggers will hit pay dirt along the way. The small guys will hit pay dirt. The corporates are very well positioned with their historic data sets and scale. I mean, think of the insurance company with 50 years of data. But the challenge for the corporates is making sure they actually execute on the opportunity. But fortune does favor the brave and the big, but it's not for the faint-hearted. So saying that for startups, there's some incredible startups which will do incredibly well. And if nothing else, get yourself a PhD and enjoy the ride. So that's it. Thank you very, very much. One? Or one question. Time for one question. Sorry, I apologize, I ramble on. Enjoy the beer. Oh.
Thank you so much for the presentation. I have a quick question.
Yep.
So you mentioned the breakdown on the industry overall, such as healthcare, consumer goods, and financial.
Yeah.
But what about the actual AI problems? So for instance, is it more language? Is it more visual? What's your...
Sorry, what, I didn't quite understand the question. Is it?
The most often found problems in those companies are they text related? Are they more visual ones?
Okay, for application of AI, what we've seen, most of the problems, a lot of the problems that are being applied are effectively prediction problems that are coming out of existing problems in big data and data science. So do things like predict which customers are going to churn, which customers are going to retain. And so what we found is it's those problems that have been tackled under the Rubicon of big data are those that are obviously the most amenable to machine learning, because machine learning is really a set of techniques that extends traditional big data. We signed vision, actually, and we haven't published this yet, but vision seems to be a very good problem if it's constrained and it's a predictable task. And you see that from the sort of the cucumbers and potatoes and manufacturing lines. So there's some case studies where I think it's car parts manufacturers were literally, they've been able to get rid of all QA inspectors because the vision is good enough. But it has to be within a constrained space, and obviously the training labeled data sets has to be very good about it. I mean, NLP is challenging because it's such a multi-dimensional problem, but you're getting some reasonable sentiment analysis coming out, but it's nice sentiment analysis, but doesn't really move the needle yet in terms of business KPIs and things. Okay. Thank you very much.